so this is lesson 1 of 6. We are looking at algebraic expressions. It's the first thing we're going to be doing. And the first thing we're going to do is we're going to look at the real number system. Now, these symbols that I've got here in front of me, many of you should be very familiar with. Okay, this N over here, anybody can take a stab in the dark. You can write it in the chat, or you can raise your hand if you'd like. What does this N and this N with a 0 over here stand for? Does anybody know what these two things stand for? I don't think it's the first time we've seen it. Yes, Unati. Oh no, and Unati's gone. You can type it in the chat if you don't feel like unmuting and speaking to me. Does anybody know? I'll give you a clue. It's not fake. It's not fake. You're correct, but I need the name. Kromla, what do we call these?
Like, should I give the definition for each and every one?
No. So this symbol stands for something. This symbol stands for something. What does it stand for?
It stands for natural number.
Excellent. Natural numbers. You're absolutely correct. And Rita is also saying that in the chat. Now, what about this one? This one that looks similar, it just has a 0 at the bottom. What is that?
That's a whole number.
Excellent. Whole numbers. That's exactly what I was looking for. Thank you, Kromla. Excellent stuff. That's it. So these are natural numbers and whole numbers. Now, natural numbers are counting numbers. So how many sweets do I have? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sweets. Now, whole numbers just start at 0 and then they go to 1, 2, and then they continue on from there. Now, there's been a bit of I think I read a mathematical paper somewhere or an article where they said that they want to merge these two things and no longer have natural numbers. Yep, I heard it just the other day that they may be trying to merge these two things, just in that when we count, we can start at 0, you'll just have nothing. But at the moment, we have natural numbers and we have whole numbers. Then we've got this funky looking one here called Z. This one doesn't start with a Z though, I'll tell you. What do we call it? This symbol Z stands for, anybody know? You can pop it in the chat, you can raise your hand if you'd like. That's it. Kromla's on fire today. That's it. Good. These are called integers. Okay. Now, integers are going to include your negative and your positive numbers, but there is a very important distinction. I can have -2 as an answer, and I can have +3 as an answer. Those two things are integers. However, I cannot say -1.4 is an integer. That's completely wrong. I can't do that. It's not an integer. So when we're looking at integer, we're looking at full numbers like -1 or -15 or +7 or +8. We cannot say -2.3. That is not an integer. Integers are full numbers, whole numbers. It's just that they're either negative or positive. Okay, I hope we know that. There's a specific reason for that, and we're getting to it in just a little bit. All right, this next one, this Q. What do you guys know about Q? I'm going to say Q and Q apostrophe. Does anybody know what these two stand for? Anyone? These are tricky though, I'll tell you that. That's it, Nesisa. Exactly. Excellent. This is a rational number. Okay, a rational number. And this one with a little copy on the top, this is an irrational number. It's an irrational number. That's it, Petty. That's it. I love your name, by the way, Petty. Awesome. All right, we've got rational numbers and irrational numbers. Now, I've written all of these numbers in a specific order for a very good reason. I've started with natural and then whole and integers and rational and irrational, because all of these, all your natural numbers and your whole numbers and your integers can be written as rational numbers, because rational numbers is one number, some number A, over another number. Okay, so if I chose at random, let's say I chose the number 3. The way I can write 3 as a fraction is I can just write it as 3 over 1. Okay, and that makes it a fraction. Now, the difference between, remember we're talking about how integers can only be whole numbers. Here's the difference. The difference is that if I have a number like 2/3, this is a fraction. It can also be written as a decimal. 2/3 can be written as 0.6 recurring. So 6 again and again. So the difference between an integer and a rational number is that your rational number can have 1 comma something or 6 comma something. It could even have negative 0.66666 because it's not just an integer, it's a rational number. Okay. Now I'm going to explain irrational numbers and then we're going to stop there for just a second because we're going to then get into real numbers. And I just want to make sure that you guys are with me. Now, irrational numbers are numbers much like rational numbers, but they're very tricky. They're very tricky. Let's say if I have to ask you guys, fastest fingers first, open up your chat. I'm going to ask you guys, what is the square root of 9? Tell me in the chat, what's the square root of 9? This is an easy one. Which number multiplied by itself twice will give you 9? That's it. It's 3. The square root of 9 is 3. This is easy enough. What is the square root of 4? What is the square root of 4? Remember to stay unmuted, guys. Oh, muted, not unmuted, sorry. Excellent. The square root of 4 is 2. And I'm bringing these numbers up because these are easy numbers, right? We know that they're perfect squares. And these are rational numbers that I've actually shown you here. The square root of 9, square root of 4, that's easy. Now, let's say I had to ask you, what is the square root of 5? Give me an answer. What is the square root of 5, guys? Now everybody's like, ah, man, it's 2, see now, and I bet you, Rita, that you have rounded off. Rita says the square root of 5 is 2.24, I need to say that correctly. Orholele says 2.23. Rita says 2.24. Unachi says 2.2. But I bet you guys there are many more decimals behind that number. It's not just you guys are rounding off. Yes, you're rounding off. So our irrational numbers are numbers that we cannot get a beautiful looking fraction for like we can with rational numbers. Now, ma'am, you're going to say to me, oh, but teacher Coco, what about things like 0.33333? 0.333 recurring is still a rational number because that's the same as 1/3. And there's a technique we can use to make it 1/3. Same with 0.66666. Over and over and over and over and over again. We can write that as 2/3. There's a technique to do that. When we talk about irrational numbers, we're talking about numbers that don't have a specific pattern. So I'm talking about numbers that will look like 2,3,4,7,9,5,6,1,2,5,2,7. There's no pattern there. It's just a random number, okay, that keeps going, and that the pattern at the end there does not, yes, exactly, does not have that. Well, if we're being pedantic, we could, but Petty, you're 100% correct. Let's leave it at that. If we had to go into it, we'd be looking at university maths, yes. So an irrational number, it cannot be expressed as a fraction. Okay, we cannot express it as a fraction. Now, I need to know from you guys, give me a thumbs up in the chat or a thumbs down. How comfortable are we with natural numbers, whole numbers, integers, rational, and irrational numbers? Give me a thumbs up. You can click on your emoji, this little smiley face, and give me a thumbs up or a thumbs down. Okay, Petty says thumbs up.
I think most people are doing
okay, excellent. I'm not actually looking at the reactions. Thank you, Teacher Kat. I see it. Thank you, Jerison. Excellent. All right, good. Now, these numbers are going to be very important because the way we categorize these numbers is going to help us to look at the difference in how we can use these numbers. Now, this big one over here, this one that I've left for last, this big one over here, what does R stand for, guys? Let me know in the chat. You can also raise your hand if you'd like. What does R stand for? That's it. Well done, Komlenreta. That's it. That's it, Snesisa. R is real numbers. Now, real numbers, I'm not even going to explain what real numbers are. Real numbers are everything. It's everything here. Everything put together. Your natural, whole, integers, rational, irrational numbers. It's everything here except the square root or the even root of a negative number. So if I had to find the square root of -2, that's not going to work. Your calculator is just going to give you an error. You're not going to be able to do that. So everything except the square root or the 4th root or the 6th root or the 8th root of a negative number. Any even root of a negative number, not a real number. Okay, so throughout your entire high school career, from now until matric, if you get to the end of an answer and underneath your square root sign, you've got a negative answer, your answer 100% is that there is no real solution. There is no real solution. That's the answer you're going to give them. It's not a real number. So let's say, for instance, you're calculating something and at the end your calculator says the square root of -36. The square root of -36 is not -6. The square root of -36 does not exist as a real number. So the square root of -36, no real solution. That's your answer. No real solution. Okay. So your real numbers is everything put together except the square root or the even root of a negative number. Now, that is all fine and well. We now understand how numbers work. Now we're actually going to look at how we can represent them on a number line. Now, we're not going to focus on all of them because they get kind of tricky depending on what it is you're doing. I'm going to focus on exactly 2 because these 2 are actually going to come out in your tests and exams. We're going to focus on integers and we're going to focus on real numbers. If we do integers, we're going to include negative and positive numbers that we can easily count with. And if we focus on real numbers will just give us everything that we're looking for. So what I want you guys to do, take out your pencil and your ruler and you're going to go onto your notebook, you're going to put it down and you're going to draw a straight line for me. Create your own number line because this is what we're going to be looking at now. Okay. Now this is where the real stuff comes in. Now we're going to have a real conversation about things we have never seen before, and we're going to start learning new things that we need to use in order to represent such things on a number line. Okay, so we're going to start with integers. That's my Z there. That's how I write my Z. You can write it however it is that you like. It's normally just the Z with another line in it, depending on how you write it. Okay, so if we look at integers, I know that my integers needs to be whole numbers. It's just they're either negative or positive. So my integers do not include -1,5. That's not going to happen. So I can't go onto my number line and do this. Yeah, I can't draw a line like that. Or let me draw it above, actually. I can't say -1, everything that way. Because now if I say that my integers are all my numbers less than -1. I'm writing that completely wrong. I'm forgetting how to write less than. Okay, -1. That makes it greater than. I'm doing the.
That was right.
It was the first one.
Yeah.
Less than -1.
Yeah.
Other way around. This is the one. This is the one. Yes, thank you, Teacher Kat. Okay, if all my numbers or my integers are less than -1, I can't do this. Because in between -1 and -2, there's -1,1 and -1,7 and -1,79543. So when I talk about my integers, I can't do that. Okay, so what we're going to do is we're going to use our algebra or any arbitrary number, we call it. And normally when we talk about an arbitrary number, arbitrary means it doesn't matter what the number is. We're going to call this number X. And you guys are familiar with how we use X. We're going to say, let's say that X is every number that is less than -1. But remember that X is an integer. It's an element in the integers. Now, I can't say it's just everything -1. I can actually name these numbers. I know that all the numbers less than -1 in the integers is going to be -1, -2, -3, -4, -5, -6. I can actually name them. I can call them out number by number. And this obviously goes on forever, but I can count them. So when I express integers, I have to make a dot at oh, I'm lying. I can't include -1 because it's not included. I need to start at -2 because it's everything less than -1. So I'm going to start at -2. So over here, I'm definitely lying to you guys. That's where we start. -2.
Can't you say less than 0?
Okay, yeah, let's make it less than 0, teacher Captain, to make it a lot easier. Okay, if we say less than 0, then we're definitely going to start at -1 if we do that. So I'm going to include -1, but I need to make a dot at -1. I can't take a dot and then connect it like that. That's not going to work because everything in between -1 and -2 is not included. So I make a dot at -1, at -2, at -3, -4, and I can keep going, -5, -6. Now, when I get here, I know that the numbers continue. How do I show that these numbers are continuing? I draw an arrow like this and like that, and then I do that. That shows that after -6, we still keep going. -7, -8, -9, -8, 10, keep going in that direction. Okay, and this is how we represent integers on a number line. Now, I want you guys to try one by yourselves. I'm going to tell you. I want you guys to show me any arbitrary number. We're going to call this one A. Okay, and I'm going to make it a little bit easier. I'm going to say there's an arbitrary number A, and A is greater than -2, but it's smaller than, let's make it smaller than and equal to
That's the
5.
other way around, isn't it?
Do I need to write it the other way around?
Yeah, because now it says
Yes,
A is
because A is greater than, yeah, greater than equal to, and then A is less than or smaller than 5. Now, I want you guys to draw out the number line and actually map out, I'm forgetting to write here, that A is an element of integers. And once you've drawn this number line, I want you to give me all the values that apply. So which values am I actually going to have that A can be? What values can A be? Draw the number line, put these as integers on the number line, and then put it in the chat. Tell me what can these numbers be. I'm going to give you guys 2 minutes. I don't think we'll need more than 2 minutes. It doesn't have to be the neatest thing in the world. It just needs to be legible. Okay, 2 minutes, go, while I fight with this fly that keeps flying over my head. Snesisa has given us an answer, and I like your answer, except you've forgotten that this little sign over here, and I'm just going to highlight it. This one over here means that A is also equal to -2. And this little sign over here means that A is also equal to 5. So think about the number that needs to come on the end of each of those. Okay, you're on the right track. Just remember that the equal sign also includes the number on the side. Okay. Okay, you guys have like, I think 30 seconds left or so. Remember, you can pop your answer in the chat once you're done drawing. Make sure that you know exactly how to represent it on a number line, and also how to point out exactly which numbers are included in the set. Okay. All right, guys, I'm going to call it. Okay, so I'm going to write out, or I'm going to draw out on my number line how this should actually look. And you guys are just going to compare it to yours. Tell me if it looks the same. Okay, so I know that my A needs to be in between -2 and 5, and it needs to include -2 and 5. So I'm going to start at -2, and I'm going to put a dot, and then at -1, at 0, 1, 2, 3, 4, and 5 as well. Okay, give me a thumbs up in the chat if your number line looks just like mine. Give me a thumbs up in the chat. If not, give me a thumbs down, and we can talk about what needs to happen. Okay. Let me know in the chat. Thank you, Unati. I see it. Muyahabo also has given me a thumbs up. Thank you. Excellent. Just let me know, guys, if it looks exactly like the one that I have in front of you. Zoom user as well. Zoom user, remember to drop your name in the chat so we can change it for you. We can change your name. I think it's Karen. I hope I'm saying it correctly, Karen. Thank you very much for your thumbs up. And Lufuno. Oh, it's Molen. Excellent. Thank you. Nice to meet you, Molen. Shomla as well. And Loi. Paulina, I think your name is. Yes, I think that's your surname. Okay. Yes, Paulina. Excellent. All right. Okay. Now I just need to ask a question. Dumb question. Should I have put this at -2 and done that? Yes or no? Let me know. If I had just put my dot at -2 and done that, yes or no? Is that correct? Is that going to be correct? Tufuno says no. So does Unati. I need somebody to tell me why this is incorrect. Who knows why this is not correct? I know you guys are all saying, no, it's not correct, but you guys need to tell me why. Okay, Unati says it has to go the other way to show that it continues. Good. Lufuno says because the numbers won't continue. Good. Rita, you're onto it. There it is. Because it isn't continuous. If this thing was just that a needs to be greater than -2, then yes, this would be correct. But because there's an interval, it's between -2 and 5, I cannot do that. Okay, now here's the big difference. Now these are integers and you guys have got them 100% on lock. Now, when it comes to real numbers, we're not going to be able to make this distinction. Okay, if we talk about real numbers, that's how we write real numbers. Then we can include everything in between here, but we're not going to put it on the actual number line. We're going to put it above the number line just to make sure that we can actually see all the numbers. Okay, so if I say to you guys that I want X to be greater than -3. Let me write that properly. Yeah. Okay, greater than -3. And I should probably do this the other way around. -3 should come first because X is greater. Okay, so I want X to be greater than -3. Okay, that means that I'm looking at every number from -3 and I'm going to do this just like that. Everything greater than -3 will be everything that way of -3, -2, -1. But because it's not an integer, it's a real number, it's going to include everything in between here. It's going to include everything in between. So I can draw one straight line that includes everything. So I'm going to do this like that. That's everything that's greater than -3. Now, I want you guys to pay close attention to the fact that this dot is not colored in. It's not colored in. Oh, and my spelling is so wrong. Colored in. There we go. Okay, the dot is not colored in. And the reason why the dot is not colored in is because -3, we didn't put an equal sign there. -3 is not included. So if I have a sign that looks like this, that does not have or equal to, I do an open dot. If my sign looks like this, greater than or equal to, and then I'm going to draw a dot, I'm going to color it in. Okay. This is the difference. Okay, now we need to pay very close attention to this. If my dot is not colored in, then we do not include the equals to sign. But if my dot is colored in, we include the equals to sign. Okay. Now, if I say that I want X to be greater than 4, and I still feel like I'm writing it wrong, but I don't know if I'm writing it wrong or right. I'm just, okay. Still feels a little weird.
It's fine.
Just a little bit weird. It still feels a little weird because I'm like, if X is greater than, then it should be on the greater than side. But it makes sense. It does make sense. Okay. I need to ask you guys, if I write X is greater than 4, am I going to color in my dot or not? Colored or not? Just tell me in the chat, colored in or not colored in. Let me know. X is greater than 4. Just pop your answer in the chat. Okay, Molin says not. Good, so does Rita. I agree with you guys. We are not going to color it in. And the reason for that is because we're not including 4. Excellent. So I'm going to put it like this. And X is going to be every number greater than 4. So I'm going to go that way. Solid line. I don't have to make dots anymore because it's not integers. Okay, solid line. Excellent. Now, if I say to you that X needs to be in between 3 and 0, what is this going to look like? Let's think about this one. X needs to be every number in between 0 and 3. Well, I know that there's going to be a straight line between, there's a dot here, there's definitely a dot here, and a dot here at 3. Am I going to color them in? Give me a thumbs up. You can even nod your head. Some of you guys, I can see the faces. Do I color it in? You can give me a nod or a not. Am I going to color it in or not? Rita says yes. Lufuno gives me a thumbs up. I'm assuming that means yes. Unati says yes as well. I see you. Mollen says yes. Good. The reason why I'm coloring it in is because it's greater than and equal to. So I must color them in. Okay, just like that. And then because it's everything in between those two, they're not integers, they are real numbers, I'm going to draw a solid line from one to the other. Okay, and this is how we represent real numbers. Okay, I need a thumbs up or a thumbs down from you guys, either in the chat or you can use your reactions. Are we comfortable with representing real numbers on a number line? Because I'm telling you guys, when you guys do functions, this is going to come up again. It's going to come up. Excellent, guys. Awesome, awesome. Okay, Unati says, can you repeat one more time? Absolutely, yes, I can. Okay, so Unati, if I said to you that I have -1 and X needs to be greater than equal to -1, and X is in the real numbers, what is this going to look like? If you're brave enough, can I ask you to unmute and we can speak through, we can talk through this one together. If not, you can give me a detailed description in the chat. I see you shaking your head. Tell me, what am I going to do? Where am I drawing my dot? Is it colored in? Is it not colored in? And how am I going to draw this? Explain it to me. I see you may be trying to unmute. I don't know if you are. Or you can also write it in the chat if you'd like. Okay. The rest of you guys can help us out as well. What do you guys think? What is this going to look like? Think about this. Just grab your ruler, draw a quick line. You can even draw. I remember when I was in school, I was so lazy. By the time I got to like matric, I was so lazy. I would just draw a line and one thing and write a 2 and draw a dot and do this. That's all I did. I didn't even bother with the rest of the numbers because I got so lazy with it. Okay, it's very easy. All right, tell me, you guys can tell me in the chat, where am I drawing my dot? Quickly drop it in the chat. Where would I draw my dot? If X needs to be greater than -1, greater than or equal to -1, and tell me what kind of dot it is. Oh, these birds are being super loud. I can't close my door. It's just a really hot day, and I was hoping I could get away with the door open, but clearly not. Okay. Okay, I know I'm going to have my dot here at -1. Okay. At -1. You guys can tell me, am I going to color it in or not? Colored in or not? Rita says colored in. I want to see if everybody else agrees with you. Mollen says yes as well. Excellent. Okay, we're going to color it in because it's greater than or equal to. Good. Right, so we're going to color it in. There we go. We're going to color it in. Okay, so now I need to ask you guys, is my dot going to go to, my arrow, is it going to the left or to the right? Left or right? Rita says left. What do you guys think? What does everyone else think? Everybody says left. We need to think about this one. Now I've got people saying left and I've got other people saying right. Which one is it, guys? Okay, all right. Okay, so remember, guys, this is the way we're going to remember it. Okay, look at where my X is sitting. Remember when we were still in grade 3 or grade 4, I think they taught us about the crocodile mouth, right? They said that whatever the crocodile is going to eat is going to be the biggest thing, right? So now here's my crocodile mouth here. It's open towards X. So X is going to be the bigger number. It's going to be the bigger number. So that means that X is going to be any number that's bigger than -2, or -1 in this case, sorry. It's going to be greater than -1. Which numbers are going to be greater than -1? It's going to be 0 or 1 or 2 or 3. That means that my arrow needs to go to the right. For all of you who said right, you are 100% on the money. Very well done. Okay. Rita's finally getting slick. Oh, yes, absolutely. That's the way it is done. Okay, we need to look at where our X is sitting. If X is greater than -1, it's going to be the bigger number. If it was the other way around, if my sign looked like this, if X needed to be smaller than -1, that means that -1 is my bigger number and X is my smaller number. So which number is going to be smaller than -1? That's going to be my -2s and my -3s and my -4s. Okay. All right. I hope that makes sense to you guys. Okay. We are running out of time a little bit. There's one more thing I want us to learn about today. And it talks specifically about how we represent real numbers. Okay. And we're going to learn about something called notation. Okay, notation, here it is. I'm gonna move this up a little bit. Notation. Now I've written some funky looking things over here that we're going to be looking at when we speak about these kinds of things. All right, now notation is just another way of me saying how to write something. Okay, and this comes off of how we look at our number line. Okay, now notation is always going to tell us a couple of things. Now, if I take my number line and I draw this, I want you guys to tell me in the chat, what does this mean? Yeah. We can call this X. We can call it X, it doesn't matter. Okay, tell me in the chat, what does this mean? Or if I've got a brave soul who doesn't mind unmuting and talking to me, you can raise your hand and we can ask you to unmute and you can let us know what exactly does this mean. Try and write it out the way that I'd written it before. So X needs to be greater than or less than something. Let me know. I want to see who's going to get this one. Good. Okay, Molin says greater than. Okay, so I'm going to put my greater than. X is going to be greater than. Greater than what? I agree with you. You're 100% correct. It's greater than. Hello, Sissy Paul. What is it greater than? X is greater than. Look at where I've put it. That's it, Snesisa. Excellent. So X needs to be greater than -2. But we are missing some very important information. Okay. What kind of number is X? Where does it fall on our number spectrum? Is it a natural number? Is it a whole number? Is it an integer? The drawing that I've given you of that X will tell us, and that's it, Lufuno. It's a real number. Good. So we know that X is part, and when we say part, This is called element because we're talking about sets. X is an element of real numbers. Okay, now if we've got X is greater than -2, there are two ways that we can express this. Okay, the first way is called set builder notation. Okay, set builder. Set builder notation. And this is what we're going to be writing over here. The one underneath it is called interval. Interval notation. Okay, and we're going to talk about that in just a bit. Okay, so when we talk about sets, we are always going to use these funky looking brackets. I think maybe we should draw them ourselves. Let's start again from the beginning. Okay, we're going to use this funky little squiggly bracket. This is what you're going to draw. You're going to draw squiggly bracket like that. And you're going to say, I'm talking about a number X. And this number X, I know that this number X that I have, this number X needs to be greater than -2. But I also know that X is a real number. Just like that. And then I'm going to close it up with the squiggly brackets. And for the life of me, I can never have the first bracket at the beginning and the bracket at the end looking the same. It drives me nuts. It drives me insane. Okay, now everything I've written over here literally says that I have a number X such that X is greater than -2 and X is an element of real numbers. Okay, that's exactly how you're going to write it. Now, if I give you a drawing on a number line and I ask you to write something in set builder notation, this is what you're writing, just like that. Okay, I'm going to give you guys a chance to try this. I want you guys to write. I don't know how your keyboards, if you're on a phone or on a laptop, I want you guys to try and replicate this. Duplicate it for me in the chat. I want to see if you guys can do it. Okay, remember this is a colon. This is a colon over here. It's very important that we put a colon there. And this is a comma. These are very important aspects of this. And these are curly brackets. Okay, curly brackets. I want to see if you guys can write this in the chat exactly the way it's written over here. Because if you can do this, that means you 100% understand what set builder notation needs to look like. I'm going to give everyone 1 minute to figure out whatever keyboard they've got and see if you guys can replicate this in the chat. Okay. Yeah, I want to remove this just so that it doesn't, that it doesn't disturb you guys from writing this. Okay. I want to see who's going to be able to get it. Actually, let me see if I can do it on my keyboard. I'm not very apt at remembering where what is on the keyboard. Oh, and Kay has done it perfectly. Well done. Unati, be careful of that extra brackets. Molin's like, ma'am, I'm using a phone. I'm 100% sure you can still do it on a phone. Okay, X such that X is greater. Oh, no, that's not it. Greater than, there we go, -2. I'm struggling too, guys. And X is an element, element of real numbers. Got it, yes. Okay, Lufuno, you're missing a -2 and you're also missing element of real numbers. That's it, Unati, and you're missing your curly brackets. The curly brackets are very important. Well done, Teacher Kat. Look at you. That's it. Excellent. All right, we're going to do one more. Now that I know you guys can actually write it out, here's your next challenge, and this is the last challenge for the evening. Okay? I'm going to put it over here. Yeah. Okay. I want you guys to write this for me in the chat in set builder notation. You've all got 1 minute because Teacher Kat and I have to go. Go for it. Okay, remember the only thing that's going to change really is this middle part over here. Everything else will look the same. Yes, for this one, you can just use an equal sign. Okay, you can just use the equal sign. Yes, Unati, but when you are writing it, when you're writing it out in your hand, please don't use the equal sign. Make sure that you're using the E symbol, because that E symbol is actually very important for sets. Okay. Yeah, okay, there we go. Okay, let's see who's going to get to it first. I think this one is quite simple though. You're going to do the exact same thing you did before. The only thing that's going to change is what it looks like in the middle. So this area over here is going to look different. You're absolutely correct. I see you. Don't use that equal sign in the middle. You need to use a comma, and don't forget your curly brackets. Okay. Snesita is on to something. She's forgotten two very important things though. K as well, and Pawalo as well. Ooh, okay.
I think we'll have to pick it up next time because I still have to do a
I think we will. Yeah. Okay. I'm gonna write the answer on the thingy quickly, just so that we can see what it should look like. Okay, remember all these numbers are smaller than X, so X is the smaller number. Okay, because I see you guys making X the bigger number. K has got it correct. All you've done is you've forgotten your equal sign as well, because it's greater than or equal to. I have colored in my dot, therefore I need to include the greater than or equal to sign. Okay,